Yeah, okay, now we are recording. So we'll start very simple. What we are going to build is, if you have checked out the code, you can also follow up. Now this is the thing. Just a second. And, yeah, let's just minimize or just move it here. We'll start with a very simple sense of Fable.Remoting. So what Fable.Remoting does, it allows us to utilize same types. Let's say you want to communicate from client to server via HTTP. It allows you to utilize the same types between the client and server, so you can share things between client and server, and then you can just use it as a request. And our example will be very, very simple, but I'll just show a little bit more different examples. Typically, what I prefer is that I create a shared project where it would be, well, it's also .NET 7 project. And here is a very, very simple domain. Our application will actually will get a string, and then it will just reverse it back. So that will be the objective of our simple thing. So this is a discriminating union. Well, this is not required, certainly. And well, we have a function, so the type that denotes that it gets a non-empty string and returns a non-empty string, and that's it. So typically, when you want to use Fable.Remoting, you will almost always want your outer type, returning type would be an async type. Because from your client side, you're going to initiate this request. And by browser nature, all the, well, AJAX or HTTP level requests are asynchronous. So there's no way you can make it synchronous. And as a side note, if you read the documentation, these are also written in the documentation of Fable.Remoting, which is a project. Whenever you pass an input parameter, here the input parameter will be non-empty string, it will issue a post request. Whereas if you instead prefer something like that, then it will issue a get request. And Fable.Remoting allows you to put custom headers, but what it doesn't allow is a query string. So typically, whenever you want to pass a parameter via request, you would want to, it will pass through post. So here's an open question to you. When would I prefer a query string instead of posting things? What do you think? When it would be advantageous to pass things via query string, which will be a simple key value pairs instead of posting via body? What do you think? Because this is not support, it's not a support scenario by Fable.Remoting, and we'll just hack it around. Any ideas?
Maybe when the values aren't secret, it's okay to do query parameters and the URL.
Well, when you use a URL, well, obviously the parameters are become more visible than the post body, but it's not about being a secret. Either way, they're not much very secret. But let's focus about the RESTful aspect and then the HTTP caching aspect of the thing. Whenever you want to query something, let's say you want to get your customers or you want to retrieve some data, if you pass a parameter via post, then you will issue a post request, and post requests are not cacheable. But let's say your intent is to query something, and you want to query by some sort of filter. You want to pass a filter. If you use a parameter by a filter, then you will issue a post request, and your browser will just cease caching it, and you won't get benefit. So this is something you may want or something you may not want. But I believe whenever you want to use Fable.Remoting via querying things and you want to utilize browser caching, then using things like a query string is better than posting data. So that's something to keep in mind. But whenever you do this, Fable.Remoting will always do a post. Let's talk about our API. We'll talk about this thing. And whenever you use Fable.Remoting, instead of interfaces, you just create a record. And in this case, I just call it iReverse API. And you can add as much as properties here. Notice the way I use it. So I like to decorate. I like to keep my domain here more visible. So whenever someone sees this file, they have quite a good idea about what kind of domain, what kind of interaction I'm going to do. And then when in the API, well, it is obvious that this reverse is just a reverse. The caveat is that once you do that, you can't see the actual thing. You need to go to definition, and this might be a reason you may not want to opt into this approach, but I kind of like it. The second thing is just well, in this case, you will see their reports is hard coded, and there's the well, we'll see the difference between these, but typically you want to define a builder function where it would get the type name and method name, and it will construct a URL. The type name would be, I suppose, this one, and the method name would be this one. So whenever I need, whenever I invoke a Fable.Remoting API, it would actually put these type name and method name into these places. Okay, so that would be your expected URL when you use Fable.Remoting. Okay. So let's go to the client side again. There's a lot of code here. So last week we talked about with Fable.Lit, and this project also uses a bit, but this is not the main focus of it. But if you're struggling, or if you find it unfriendly, just let me know. I can talk about it. In particular, let's just collapse as much as we can for starters. In particular, our code involves a model where it has a value with none of the string. And well, in this case, this is the only thing I care. So this part is somewhat reserved to Fable with the Elmish.Bridge. So we're going to talk about it later. The message is also, we are not concerned about it. The only thing is just we are caring about these two. So whenever someone, there's a reverse button, there will be a reverse button. Whenever someone clicks to that reverse button, it will actually reverse this string, given string, and then it will return the result. And then what we do here, how we're going to use it is once you define, by the way, if I just revert to the packet that references here, not here, so for the client side, let's just discover what are the packages that we're using. Well, for Fable.Remoting, we need the Fable.Remoting client, and that's it. Okay. The others are just something else. So there's the Elmish.Bridge, Elmish browser. These are others. So this is the only thing you need for Fable.Remoting in order to interact. And let's just go back. So here we initialize our Fable application, Fable.Lit application. You'll see there's some bridge config, which is something to ignore for the time being. And this is the command actually we are going to execute it. So whenever we want to issue a Fable.Remoting command, we're just going to execute this command. In the init part, we are actually specifying a non-empty string called test, and it will just have some default values for some counters. And our expectation is this: whenever a reverse click message is issued from a UI, okay, it's here, we would run this command. And then our expectation is that with this would also run the thing. Let's say run this command, passing this thing, and just will get the result. And here I use this older approach where the command that was going to perform, where it will pass the input to here, and whenever a successful result, which is that it doesn't even ask for failure, whenever a message comes from that, it will actually wrap the message into that, and then it will reissue it here. Okay, and then we'll just print the result. And that would be it. Here you can see there are some sort of puzzles here, which we are going to cover, but these are specific to remoting. But actually, I just realized that this might prevent even to run the demo itself. But it's okay. think we can still cover it together. So this is the client side of the Fable.Remoting. So that's all you need. If you just do it to recap, all you need is to add this Fable.Remoting into your project, all right, and define some sort of which I'll talk about why this is hard-coded. It doesn't have to be hard-coded. You define some sort of type name, a builder here, and where this is used. If you look at the server side, client side again, we have to build a proxy from client side to communicate to server side, and this code just essentially does that. So what we do is, again, we are utilizing this API of Fable.Remoting, where we create an API. You notice we are passing this builder here, okay, with route builder, and then we create a proxy here. And once you do that, you get an API where it has a reverse function, which you can pass whatever input you want, and then this will issue a post request to the server side. And once the message is returned, it will wrap the response to this reverse result, and it will get the response. Any questions so far? Anything you're curious? Is anyone familiar? Everyone familiar? Is there anyone who has never used Fable.Remoting before? If everyone uses it, I think I'm stating the obvious so far, I guess. Okay.
No, I haven't used it before, but so far I would say it's clear for me, at least.
Okay. I think we have covered it extensively in the workshop. So yeah. So in that sense, but let's say, I just want to before running this, let's say we would like to, maybe I can show it the live demo from another example. Notice I've created this API by just hard coding this 5,000 port. Why this is 5,000? Because actually there's a socket here. Well, not socket. Sorry, I'm just going. We are going to run this. The client side, actually, when we want to run this application, you will see that the client side will be running through a Vita server, and that the port will be different than 5,000. It will be something like 5173. If the port number were the same, then we wouldn't need this kind of thing. And this is actually the case in the other project. I'll just show you in the live case, where okay, just sorry. The shared. API. So here you can see actually the same thing here, and you see that the difference the difference is that it starts with the /API. There's no such thing called port number. Now I'll show you something very important, and you will not find it anywhere else. So just listen to me very carefully. If you have, probably this is something you don't know. When you're working with Fable and ASP.NET, right now during the development time, I typically use Vite, or you can use a Webpack. But what would you like is you want to run everything under ASP.NET. You don't want your Vita server to get in your way, okay? And in the current workshop, what we're doing is just actually Vita will get in the way. But in the actual case, when you're doing development, you don't want the Vita to get in. You want everything to be hosted by ASP.NET so that you can just use the actual port that is hosted by ASP.NET. In that sense, you need to bridge ASP.NET with your built environment. And the way you do is this. In your server side, you grab a package called, where was it? Microsoft ASP.NET Core SPA Service Extensions, okay? You need to install that. Once you install that, you go to your program and you specify, find it here. Yeah. So this brings actually there's also this you need to introduce this Microsoft ASP.NET Core SPS services and React development server. So we are not going to do the and this project also doesn't use React at all. The way that we use it, actually we are abusing the fact that once you bring it up, is that you can use SPA middleware. And once you use middleware, use SPA middleware, whenever a request comes, an unhandled request comes, I mean, for other than all the middlewares, it will forward that traffic to your Vita server. Okay. In this case, we are saying that, well, my SPA lives in some folder, which is the path, and it actually runs under this port. And actually, whenever my ASP.NET application runs, I would like to run this watch script. So that means whenever my ASP.NET page runs, actually it will simultaneously execute the npm run start, which will run the Vita server. Where does this come from? So if you look at for example, in this project, there's something called watch here. Oh, is that no? Wow. Okay, it's here. The watch here. The watch will start the client workspace, and it will go. If you're not familiar, it's not that important, but eventually what it will do is it will start the client side server. This is only for development time. It's not required for production, because production is a different we are using a different strategy. It will actually start this one. And the fun fact is ASP.NET SPS services will wait for this hard-coded text until that. So what I'm trying to tell you in the overall, there's a way to get rid of this hard-coded port if you want to integrate, but that's not what we are doing right now. Okay. So this is what we do for the client side. Let's look at the server side of it before we try to run it. Well, this is typical giraffe thing, nothing here. And what I do is just because there's a shared project here, I just share this thing with the client side, server side as well. And actually, all it does is it just implements this function here. And what it does is it just reverses the string, and then just returns the string. So there's nothing here. And how is this registered? You create an HTTP handler, and the package you require is this one, Fable.Remoting giraffe. Okay. Once you get it from the server side, you can just bring this module, and once that you just create this your HTTP handler, and then you just register your handler to giraffe. There's an error handler. You can see the documentation. You can choose a propagate or ignore. Both will emit the errors. If there's a error, ignore will just return a generic message, where propagate will generate a more detailed message, just in case you want to get it. And basically, this is the client side. And whenever the server side issues a message, and this code will be invoked. Okay. I think at this point this won't run, but I think we'll be able to see because the reason it's not going to run is probably we're going to fix those missing marks. But that's fine. We will see it running all together. Now let's look at the more interesting part. Probably that's you're here, which will be the Elmish.Bridge thing. So Elmish.Bridge is another project. There's a documentation here. Okay, which is I find it very confusing. So I'll save you from reading it. I'll just describe my own thing. But there's one thing I'd like to highlight. The challenge with the Elmish.Bridge is that what Elmish.Bridge does is just you know there's an Elmish loop already on the client side, and then we also create an Elmish loop on the server side as well. then for each client, there's an active WebSocket, and there's an active dedicated server-side state that is specific to that client. Okay, for every client, you get a dedicated Elmish loop on the server side, and for every client, well, obviously you have an Elmish loop on the client side, and they can just send messages to each other out of bound through a single socket.
Just one question: what is the lifetime of this of the loop itself? Is it only via components, so it's only active when you have the dedicated web page open that has a client-side Elmish loop that creates a responding server-side loop as well, or is it all the time when you're starting it up available?
So the life cycle starts like this. So the client initiates well, I want to open a connection, a WebSocket connection. And the server side then starts an Elmish loop for that client, specific to that client only. Okay. Then, as long as the connection is active between them, it's not disconnected, the server keeps the server side Elmish loop alive, and your state will be stored in the memory. If somehow the connection got disconnected, then you can also configure server Elmish
connection.
Not like that. So it actually can notify you that the client is down, and it actually shuts down the server side loop.
Okay.
And it is your responsibility to restore the state from client side once more.
Okay.
Okay. Or alternatively, you can, for example, what I do in practice is that I create an actor that's dedicated, that's alive. And even if I lose the server side state, I can just bookkeep it. Yeah, grab it from the actor, maybe, or whatever it means. You can just store it to disk or to your database. But that's the life cycle. That's just how it works. One problem with that, this looks simple, actually, the idea, but let's just try to draw it here. The challenge, especially, so there's something called a Elmish loop. So let me just, if you look at the monolithic Elmish pattern, I assume if you use Elmish, you're somewhat familiar with this pattern where there's a main and there's a child and there's sometimes grandchild of it. Okay, and what you do is in the update function of, for example, your main function, you just call the child's update function. Yeah. The challenge is, how would you orchestrate the message such that, for example, if you have such a hierarchy here on the client side, this is the client side. Actually, what I'd like to do is I would like to have some sort of a mirror image, a symmetrical mirror image of this thing in the server side. Okay. So if there's component 1, then there's a server side component 1 here. And if there's child component 2, child CC2, let's call it CC2. So I build up same hierarchy here. And now I'll show you an example. And after this talk is finished, think about it. And it's a challenging example. How would you do it by yourself? Try to imagine you don't use this kind of mechanism. You want to do what? I challenge you to think about that problem after I talk about it. But basically, the problem is that obviously, this represents the client state of CC2, and this represents this server-side state of CC3. And whenever a message is just to come from here to here, I would like it to be delivered to here. Okay, and I would like the return message to also come back here as well. So the problem is to be able to orchestrate this traffic properly, and this is the challenging part. Because otherwise, you will end up with one single loop here, and you try to make it like a global God object here, okay? And this might work for a while, but it's a limited option. So this is the problem we are going to solve. For that, let's just, before we just again see the live example, let's just visit our API. What I like to do with the server-side and client-side messages is that I like to So our example is this. What we're going to do is this. What we're trying to build. We're going to add a button, create a button that would add timers. Okay. So when each time I click on add counter, it will add a new timer, and each timer will have its own facility to start and stop. Whenever I click start, it will somehow from server side, it will start a timer from server side, and whenever the timer kicks in, it will update the client, and I can add as many timers as I want. So there could be multiple timers, and I can stop and stop in each of them individually, where all of these timers states will be stored in the server side. It's actually a bit challenging thing, if you imagine build such a thing, but we'll build it somewhat easily. So for that, we are going to issue some messages, and the first thing we're going to do is what I like to do is we're going to cover messages from client to server. So this is a module, and just like regular Elmish pattern, where you have the parent messages and the child messages, I follow the same pattern, and there's only one message that is delivered to be the parent component, in this case the C1. That would be the add counter. And for each child counter, which is there could be n number of child counters, I'll just wrap it into a counter message. So I assume you are somewhat familiar with this pattern, where you wrap the child components messages into a single case discriminated union. This int is just like an identifier number, like my first counter, second counter, third counter, fourth counter. So I can just add. So it's just like a tag or label. It acts like that. Whereas the actual counter, through the WebSocket connection, will be able to issue start counter and stop counter messages. Okay, for each counter, and that will be the it. Let's look at from the server to client side. I would highly recommend to use this kind of convention, because then these messages otherwise become very confusing. You'll start to lose. Well, was this a message from client to server or server to client? It becomes very confusing. So this kind of methodology helps. For server side, these are the messages that is sent from server side to client. You should almost always state your first message to be server connected, because what you want, first, the client to acknowledge that the server Elmish loop is ready. Just because I started the WebSocket connection doesn't mean that I can just start bursting my messages. I would like to wait until server says, okay, I am connected to you. I'm ready to listen all your messages. So I'd like to wait till that moment. For that, I create a notifying message where the server will send this message whenever it is initialized, which is I call the server connected. Then there's a corresponding message for each one. So there's an add counter. This is the reactionary message. I'll counter edit as index 5, for example. Okay. And for each counter message, again, it will actually, this is just a wrapper over the child component, where the counter message is just like it's just hey, there's a counter and its value is like 5, 6, 7, 8, 9. It will be incrementing. So this is the model. This is the message traffic, but we're going to use. Is it okay? Is it confusing? Maybe seeing an example would be better, right? Okay. As for the endpoint, again, we have this. Well, if we run through this socket thing here, let's see how we initialize the Elmish.Bridge from the client side, and how we incorporate it in the loop. I'll cover all of these once I make these things running. Well, in the app side, what we do is we have this reference from here, Elmish.Bridge client. Okay, and the thing is, yeah, sorry, just switch to here. You need to build a bridge config here, which specify the endpoint. This one says that, well, I would like to use the URL as is, or you can just use a relative, this kind of options here. I'm not going to cover that. This one says that whenever a message comes from server to client, I would like to map it to my client messages. And what it does is basically it says that whenever a message comes from server side to client, I would like to decorate it with the remote tag. Okay, that's my intention because I'm going to use it. And what if it's a message to my child component? Then just like from, as you would remember, in a monolithic Elmish application, you call from parent update function to child update function. I'm calling the child map function. So now I have init, update, and map, actually, not just init update. And actually, I misnamed it. So it's counter map, but actually it's counter map client message. So this is an identical. We'll visit that. So it's just forwards that if it's a message to a child counter, I will just forward it to child counter, and it's their problem. Okay. Once I have the bridge configuration, I just utilize this with bridge configuration, and then I'm good to go. So let's look at the messages here, and let's look at our view here first of all. We have an add counter button here, and whenever I have add counter button, it's all it's going to do is it will actually it will issue this message. And what it does is our current model will have a counter number, which is stating that, well, these are the 5th counter, 6th counter, 7th counter. It will increment. Notice there's one thing here. I just decorate my update function with the bridge send, which is coming from here. Where is this coming from? Bridge.send. So this is a static method. And this function is the one that allows us to send messages from client side to server side. And my question to you now is, whenever we add a counter from client side, what message should I send? From do speak, Kevin.
Client to server at counter.
Yeah, perfect. That's good. And that would be it. So that's actually the message we sent. And why I use effect? Because, well, I don't even have to do this, right? I can just do this as well with command.none, something like this. It's not required because I'm not even accessing to dispatcher, command.none. But let's just be a little bit more proper, tidy, make a little bit idealistic approach. So I still like to wrap things into command if it involves a side effect, even though I don't use a dispatcher. So this is a dispatcher here, okay? And if you're familiar with Elmish.3, this is command of sub. In Elmish.4, this has become command of effect. So it's just renamed for this kind of thing. Okay, then let's look at the second one here, second puzzle. This one invokes that whenever a counter is added, so the server side says that, well, I added the counter. So the first thing I would like to do is that I would like to initiate the counter from the client side as well. So what this will be? This is standard monolithic Elmish loop pattern. Let's look at the counter here. It actually has the init update function. Which was it? So it will be something like that, something like command that. Sorry, not command. Counter that.
Counter that in.
Yeah, that's true. So this is what you do in a typical monolithic Elmish loop, right? You just, whenever you want to initialize a component, you just initialize. You call it initialize, and you might get a child state and child counter. And what I do is just I just set the state, add it to the counters actually, and I use this command.map to convert the child's message into parent's message. If you're not familiar, this part might be confusing, but again, very standard Elmish thing we do. because if you look at the message here, the counter message is actually a wrapper over child messages. The reason we do this is that whenever a message is targeting a particular counter, I would like to wrap it into a counter message so that I can, in the parent update function, I will be able to forward it to the relevant child counter. So that's why I'm wrapping it by the parent. Okay, but if you're confused, check out some standard Elmish applications. This is a very common pattern. Cool. Okay. Then we can have counter messages. So in this case, what I would like to do is, you can see that I'm actually calling the counters update function. There's a child update function, and child update function is needing of this bridge send. Okay, which is the type. Notice the type. The bridge send is actually now is the client side. It's not the client to server, but client to server the counter message, because that's the child type. Okay. In order to do so, I need to adjust my bridge send function. So this am is the message. So what will be here? I'm trying to construct a bridge send.
You need the.
Oh, this is difficult, I admit, but actually also simple. It's one word.
Bridge send, I would guess.
Yeah, that's it. So basically, whenever child wants to utilize the bridge send, I'm telling that, well, whatever you want to send it, I would like to wrap it into this one. And only then I will allow you the actual bridge send. Actually, this is the only way. You must do this because the code won't compile. Okay. And actually, remember, this is what I'm trying to achieve. So I'm trying to build up this kind of traffic where each component message is delivered to the correct child component. Okay, that's why I'm constantly wrapping things up. Once I have this bridge send, then I can just send this bridge send to the child. And well, this is just the state of it, the message and the state. And the state of that counter is just the ith counter is just, well, it's just the counters are an array. And once I get the child state and child command, I just do the same thing. But the difference is that I actually find that counter that is equal to that. Essentially, I'm just actually updating the counter. Whenever I change this counter, I find that one in the current counters, and then I actually use this counter instead of the current counter. Okay, this is just looping inside the MapI with the list. Why there's MapI? Because my counter numbers start with 1, 2, 3, 4, 1, and actual the counter index would just be 0 indexed. Okay, so it finds the counters, and then it will actually use this counter instead of this counter. And then once I have a new list, I will be setting that state. And again, similar thing. This is just the identical to this part. I'm just using command.map so that the child can issue a message, and it will find the correct target. And I guess that's it. I think there are some sort of. Oh, I forgot to miss some messages, but that's about. Okay. Anyway, so this somewhat concludes the client side of the activity, and we'll see in a moment. And just once it runs, we'll just make another walkthrough. I know it's not easy to digest, even though what I'm telling to you, I also struggle a bit. Oh, before moving that, let's just visit the counter itself. So this is a child counter. This is far simple. The model is just a counter, and if it started, the messages are here. You can see that set value, start, stop, remote, and whenever you set value, it just updates the model. There's no effect here. Whenever you start, which we have a start and stop buttons here, they will actually change the state, as well as they will issue those start and stop counter messages from client side to server side. Okay. And this one is just actually whenever a message comes from server side to client side, which I decorate like his, it will actually reissue another message, set value, which will come here. Okay. Notice we were going to update the timers from the server side. And that's it. Let's visit the server side quickly. In the server side, we will see another Elmish loop here. Let's start from bottom to top, maybe. So how we are going to use the socket? One of the things you need to do is you need to use WebSockets. This is a standard ASP.NET thing. It's a standard middleware. The rest is very standard thing. There's nothing interesting here. Now we have the server thing, and let's see what the server does. This is the Elmish.Bridge thing. Expand it. So once you, let's also see the install package here. And the package is that Elmish.Bridge, no, sorry, that's the correct one, server one, references. Elmish.Bridge giraffe. So since because I'm using a giraffe thing, then I just need to bring this package. And then also I bring up this Elmish.Bridge and Elmish open up namespaces. Once I do that, I have this access to this bridge that make it MK server. So just like standard Elmish applications have make program, we have make server here for the Elmish loop. And just like standard Elmish loop have init and update function and the view function, we don't have init view here, but we just specify the endpoint, the common endpoint, the socket. Let's just see, remember what it was. Socket here. I don't need a port. And the init and update, which is the main init and update function. Okay, just like regular Elmish. And you can add console trace if you like, and then you just call bridge run and draft that server. Yeah, so I suppose this belongs to giraffe itself. Yeah, I guess so. And that would give us a server thing. And once you have the server, you can just add it to your handlers, and that's it. You're good to go. Okay, this is how we make the initial setup here. The next thing we do is, since we have established the init and update, let's see the contents of this init update. What's going on the server side init update function. Unlike the regular client side init function, the server side counterparts of it will take another additional parameter called client dispatch. And you can see it here. So it looks like a regular init function, but it also takes a client dispatch, which actually the type is dispatch server side to client. And I think you can guess what it does, right? Its duty is to send messages from server side to client. And here, in my init function, the first thing I do, well, I like to do it via command actually, but anyway, you can do it directly as well. The first thing I do, as soon as the loop is initialized, I send a message from client to server side to client called server connected. Then I set up my state, and that's all it does. Let's look at the init function. Oh, there's a hub here. No, that's not required. So earlier we talked about messages that would come from client to server, and then let's discover that. So whenever before even that, let's just talk about the messages. You can see that just like the regular update function, this has an extra parameter here. But it also has its own message type, and this message type is the one that that allows us to to define our own messages. And the remote messages category would be like, well, I call everything from client side, coming from client side, decorate with the remote, and everything else is just my own messages. In this case, it's only the counter message, which actually triggers to the child component. Okay. I'm just curious where, while talking to you, I'm just curious where I have defined this one. Yeah, it's just that. And how is this going to be wrapped into that? I think I'm going to wrap it myself. Okay, let's see. So whenever, we'll talk about this. Whenever the client side sends me a message called add counter, what I do is I change my current state and I just increment a number, and then I get the current number. And what will I do here? Oh, there's a hint here. Whenever I need to counter, it's very obvious, right? Okay. I'll just init counter, right? So this counter is the child counter. So it also has that, you can see that just like that here, you're actually initializing the child counter here, and which has its own state and own loop. Okay. And then I just add it to the thing. And then I also say, well, I would like to, whatever that command, if there's any returning from that command, I would like to wrap it into my map function, as well as a side effect, I would like to issue a message from server side to client. Call it the client counter edit. Okay, so that's how I issue a message. Similarly, whenever a message comes for any particular counter, I just call the counter at remote. Sorry, I just extract the message out of it. Sorry, I just wrap it in the counter remote, and then yeah, and I just reissue it as a counter message, which will come here, and the counter specific messages will be land here. That's how. If a counter specific message comes from client to server, it will actually recursively come to here and it will just land to the correct counter. It will find the counter, call its update function, etc. This one is just similar to what we did in the other case.
Yeah.
Yeah. So what will it be?
Client dispatch.
Yes. Did I mess up something? Okay. So yeah, I know it's a little bit confusing, but that's the mechanism we end up with. And actually, there's only 2 puzzles left. Now let's look at the child side, child counters. A child counter on server side has a count of, it's just timer. There's a cancellation token here. And the reason we are going to use the cancellation token is that there's a timer, and I just decided to use it this way. Whenever the client says, well, I would like to start a counter, I will actually convert that message, the remote message, to my own, to a message that I would understand, which is a start. And whenever the client says, I want to stop counter, I just want to convert it to a message that I would understand myself. And what a start does is it creates a cancellation token source, and then it stores this token source in its own state, and it issues this command. And what this command does is just actually it starts a timer. And it says that, well, I want to start an asynchronous block. And while cancellation token isn't requested, I would like to wait for a second and do what? So if you look at the messages here, what do you think? Which one would be? I would like to dispatch some message here.
Tick.
Yeah. Once a tick message is dispatched, well, obviously it will come here, and I will just tell the client, oh, well, what's my current value? And then I will increment the current value. Perhaps I can increment the counter here before. I think maybe it's more right before. So I'm just sending, it's like sending this 0 2 times, so that you will see a delay here, but it's correct. And whenever someone says stop, what will it be? So I need to, how can I stop this timer?
Send a cancellation token.
Close. So we have the token source and you just call cancel.
Okay.
And this will eventually will cause it to be canceled. And I guess that's all. So we have talked a lot without actually seeing anything in the action. I think we deserve to see some results if all this talk was nothing for something. So because this is there are two different projects. One is the server side, one is client side. In this mode, I need to run server side and client side separately. So I'll just start the server side project here, which business port 5000. I'll just start another terminal here. And in this case, I'll just go to client here and I'll call npm start. The reason I'm calling npm start is because this has a VTech config here. And actually the start is, it does Fable watch and run VTech. So that's why. So this starts the client side. I'm having some issues with VTech recently that it would require me to sometimes run multiple times, but let's just wait for the compilation to finish. Yeah, we can try. Now we can see everything we talked about in action. Unless my browser crashes, which just happened. Very good. Okay. So let's see the things in the traffic as well. Network Explorer. Let's get all. Maybe let's just focus on the fetch first of all. So there's a message here. I can type Anur or anything you type. Wow. It's not the first time it's failing. Let's see what's going on. Actually doesn't even issue a message here. Oh, wait, I forgot one thing. Yeah, so that's the reason. So we forgot one of the puzzles here. which is, what was the line number? 49. Yeah. So as I told, well, this is somewhat obvious. I'll just quick pass it. So if the server is connected, then we detect that server is connected, then the server connected will be true. And that will be it. So this way we can actually track if the server is connected. And actually, ideally, you don't want to allow the user to, I don't know, to press the button before this is true, right? Because it doesn't sense. But notice why did we get error? Because the first thing happened when we opened the page, this message has just come, even though we didn't do anything. And the server is connected already, which we will see. I think maybe we can see. If you start the socket, look here, you can see that every time I reload the page, the server connect message comes from server to client. And why it comes, I'd like to remind you, is that the first thing we do here in our init function, we just dispatch this thing, okay? And that's why it comes. And once it comes, it will land here. And it's just setting the state. Okay, now we can call this test thing. So every time I call this thing, you can just see the reverse thing going out. So this somewhat has the Fable.Remoting uses something called simple JSON serializer. It just has a built-in serializer inside of it. Somewhat just sends it via serializing and posting it. And use a simple post, and it is possible you can do it manually if you don't have a Fable client. Another client can do. And I want to highlight that Fable client, remoting client, as well, works in .NET as well. So you can, this could have been a .NET application, and that's the part of it. Let's look at the interesting part where the socket is just connection here. Can I actively see the messages, or just I have to click every time? So we add a counter. So once we add a counter, you can see that we issued a message from client to server, and then as a response, we get the counter added, and there is an index 1. And then we can add another one, and another one, and another one, okay? And then we can start each of counters, okay? So then it will start 1, 2, you can see that. And this will start as well, and this will start as well. And this will start as well. And we can stop. It's actually fairly complicated to achieve such a thing. I mean, at least for me, I'm just imagining how would I do it without Elmish.Bridge. It's pretty difficult to manage. Although I also admit the code here isn't very straightforward either. But all I do is I have a counter arrays right here, counter list, and I'm just bookkeeping. And that's all I do. The important bit is about that you every time you add a counter here, you just add here and add here 1. And this is like a number 7, number 8, and this is number 7, and this is number 8. And this one pushes its value to here, and it will find the value of here, okay? And similarly, this one pushes the value here, and it will find the value here. And similarly, when I say stop, for example, stop timer, it will find its path and it will stop this timer only. It somewhat requires some practice and this kind of methodology, systematic methodology, to build up such a mechanism. This is the difference between Fable.Remoting, where it's simple because once you have a request response cycle, it's simple, right? I just click this thing and I know what we'll get, so I don't care. But once you have a WebSocket, then you see that there are multiple components actually actively simultaneously speaking to each other, and it's not easy to orchestrate such traffic so that it knows its path. Yeah. Okay, so actually this is the essence of I'm going to talk. There's nothing else I'm going to discuss, but if you want me to review any part or ask questions.
So I've just got a question about how do you scale this? Sort of like normally with Signal R, you would use something like Redis to put it across multiple cores and multiple servers.
Scale in the sense of, I'm gonna say, if I have 1 million counters or something.
Yeah, I don't know really, sort of like just how in our apps, sort of like every if it's got running on multiple cores, none of those cores can really talk to one another.
Okay, well, I somewhat get what you're trying to say, and so there's one thing. This under the hood uses the mailbox processors, even on the server side as well as on the client side. Yeah. And mailbox processors somewhat create a fiction. So I actually, now you think that there's a dedicated thread running for each of which, right? Then you may think that, well, there's a thread running for each of which. It really creates this kind of illusion where you think for each counter there's a thread. And if you have 20, then but actually that's not what's happening. So mailbox processor in F# are somewhat very, very efficient. They somehow use the same thread using an underlying scheduling mechanism, something like a thread pool kind of thing.
Yeah.
So you can scale very well. I would say, I think I can add 1 million counter and that would work.
Yes. No, I understand that bit.
Yeah. But your question is valid. It's just
no, I was just sort of like asking, do they have a sort of like a bit in the Fable architecture that does that? But
all it does is just uses the
yourself. Yeah.
So there's another thing actually. There's something called server hub, and then once you have the server hub, you can actually, for example, maybe I need to see the documentation. You register the hub. Yeah. So once you have the hub, you can just say, well, so you create a hub instance, okay, here like that. And then you can say that, well, I would like to use this hub. Once you have the hub, what you can do is you can just broadcast messages. Let's say you want to have multiple clients hub that, for example, broadcast, okay? It will send a message to all client Elmish loops. Now there's an intriguing bit, it's called the broadcast server. What do you think it does? Any ideas?
All servers. Or broadcast from the server to all the other clients.
But we are on the server. We are already on the server side here.
Broadcast to all the other servers in the hub.
Yeah, what it does is actually it broadcasts all other Elmish loops on the server side. So you can send a message to server side counterpart of the Elmish loops for all other clients. Okay, and there's this one a little bit more slightly advanced version of it. There's a hub send client if. So you can just say, for example, the X is the model and its counter number, I suppose here. So you can just make it conditional. For example, someone asked me earlier, he has lot of different clients and he wants to send the broadcast a message, everyone except itself. And what I suggested him that you could just create a unique ID for each client and then send client if the unique ID is different than mine.
Yeah. Something
like that. So you can just orchestrate this hub. It's just this kind of thing. And in some sense, this is, I find, is more powerful than SignalR, especially it integrates well with Elmish. And you should again be aware though, if this connection somehow is connected, then it is client's responsibility to put it back. I think this also has something like a breach that's went down kind of thing. So this says that, well, whenever the connection is down, you can issue some message here. So I don't know, something like client disconnected, kind of thing. And then your loops on the server side can clean up, for example, store their states or whatever. So that's one additional bit. Well, you have the example. So as I said, I know it's not very trivial to grasp it, but at least mentally, I challenge you. I invite you. How would you design such an application? Try to think about mentally by yourself without using this kind of well, it's on the Chrome. Yeah, without this kind of mechanism, how would you design such an application? You would see it's not so trivial.
Yeah.
Any other questions or?
First, thank you for doing this. This is great. Is this presentation going to be on YouTube or somewhere where I can, or we can refer to it?
Yeah, I put all my presentations on YouTube. So this will be also on YouTube. My channel is on. Where? Oh, if I can only go to this one. I don't have so much videos, but actually, this is the 4th video for this sequence. So I just posted the chat just in case you're curious. So the first one was there's some sort of crafting the perfect playground, and it was just initializing with giraffe, and the third one was about mastering Elmish and Fable.Lead, and this one was about the WebSockets and remoting. There's one thing I wanted to highlight actually. So I just mentioned about the query string in the first case, and how would you do that is well, I'm not sure if you're going to, but I think there will be cases where you might want to pass a query string, and Fable.Remoting doesn't support it. So the trick I came up with is the following. Yeah. So here, for example, I just in my API I also ask an explicit parameter of a query string, and then I pass this query string to the API builder, and the query string is passed as this one. Every time, basically every time you pass this thing, you will get a newer version of your proxy. But I checked Fable.Remoting's code. Actually, the client-side proxy is just nothing. It's just create a class. So there's no harm creating a different API or a different client-side proxy every time you send a message. And basically, once you do that, let's see this API root builder. What it does is, in case you need it, you want to pass a query string. Then all I do is it called this function, and you see that there's a query string here. And if there's some query string, it actually concatenates with the question mark. Otherwise, just a chance to send it. So this is one trick. You can pass query string. You may think this is not important. Hey, I don't want to bother this, but if you're running queries against client side, sorry, from server side, as I said, you might want to consider a GET request. It's browser caches are very underrated, but it's important if you need a high performing application.
And can you tell it what caching sort of like thing to use on from the server?
Well, first of all, the server side can issue cache headers explicitly. Okay, says that I would like to cache. So you can say you can pass some caching headers, which is recognized by browsers, and you can give some sort of duration and this kind of thing. Otherwise, it's a little bit more about browsers heuristics. And if you're passing the data, browser won't probably cache it by default. But let's say you're issuing a like an image or something like that, then the browser uses some heuristics to cache it for some duration.
Yeah, But in terms of on the server, can you get through to the sort of the underlying response object that's being used, or is it
Yes.
totally hidden?
I mean, well, you can write whatever you want eventually. I mean, this thing, for example, just find you as some code sample here. And so this is actually counter function, and where for example, it's a signing function. Okay. And for example, you have the context. For example, here I can access the query string that's passed by the client side.
Yeah.
As well as to verify, I think. For example, I can use context.signin just to sign in, send the cookie. And I think from here, from context, you can access the response object, and you can just write whatever you want.
Yeah.
And this is a pure giraffe thing. Yeah. So, and this is a Fable.Remoting, I mean, thing. But you can pass the HTTP context explicitly the way I do, and once you do it, which is how I do it. Let's just see.
When you're building that up, you tell it that you want the context as well.
Yeah, here you can see, actually, it's a good example also.
Yeah.
Actually, apparently, Fable.Remoting has an ability to give you the context.
Yeah.
Okay. And then I just pass it, and then you can do whatever you want. From context, you can access the response, and then you can write all the headers or access the request.
It's sort of like all the Fable stuff I've ever seen is just totally Fable client and server, and of course that's never the sort of like the situation that you're faced with. You've got sort of like a massive application that you've got to try and stitch this into somehow. Yeah,
that's true. Another example perhaps I want to highlight a little bit briefly. This is a simple code snippet, but it shows that there's also Fable.Remoting, but it's from Fable from .NET to .NET. So it's a .NET application. So you construct a Fable HTTP client. You can also use this for mocking and mock kind of testing if you want. Here I specify the timeout, for example, 4 minutes, and I create a server, and then I just call. There's a real code, by the way. That's something I use. I just pass the call. So this is also a different way to. But this is documented. You can see it's not something super interesting. Yeah. Okay. Any other questions? Okay. And thank you for listening. I hope this is helpful. I know that you need to go through. It's not super trivial, but I hope this. To be fair, it's not very trivial to go through something like WebSocket programming, this kind of thing. And when I read this, I find the documentation very confusing, and it doesn't follow any pattern. It doesn't discover this pattern that I tell you. It doesn't deal with that. You just have to invent your own. And at that point, I was considering to drop using Elmish.Bridge because it wasn't addressing how would I do a real complicated application rather than sending simple messages. And then it's just the thing I didn't cover, which you might be interested later on. That there's some sort of asking API. He just added, the guy who just added in the 5th version, which I never used it. But you might find it convenient to a degree where, for example, you can just directly ask from server, from client to server, just like that, instead of all the magic I'm going through. But I'm still, I mean, this would work whenever the client is initiating things. But whenever you need this kind of architecture, well, where was it? If you have multiple child components, and I don't think this will help you out. This only for, I can only think of this would work only for simple cases. You need to do the message wrapping, etc. It also supports things like, for example, you can have multiple named. There's a named bridge called, well, you can name the bridges. For example, there's a chat channel. I think they still use the same socket, but It just groups them in, with different names, which is something you might consider using it. Thank you all. I'm stopping here. As I said, I'll share the recording through YouTube, and you can catch up from there. I wish you
Thank
a
you,
good
Anna.
weekend.
Have a good day.
Thank you. That was great.
Thank you.
Yeah,
Thank you. Bye.
for sure.
Thank you.
Thank you. Bye.
Bye.